There we go. Okay, so if you guys have questions, just unmute yourself and I'll go through them. I have the Unit 9 review, and then I also have that 9.4 and 9.5 review that we did in class. So you can ask from either of those and I'll be able to help.
There's like a chapter 9 review and a unit 9 review. Are we supposed to do both of those?
No, you're just supposed to do the one that I have pulled up. So the other
Okay.
one is like the ones where you make your own review.
Yeah.
So don't do that one. Just do the one
Okay.
that has the questions.
Okay, thank you.
So like when you have the slant asymptotes, is the only way that you're able to tell where the graph goes is to like plug in points and things like that?
Yes, and it just depends on normally like you'll be given points and so you'll just connect those and then you should be able to tell where the other one is just based on how the graphs don't meet. Like at a vertical asymptote, one will be pointing down and one will be pointing up, so they'll be going in opposite directions. But if you are not 100% sure where it goes, you can always test points.
Okay, thank you.
Do you guys have any specific problems from the review that you want to go through?
Can you do 13?
Uh-huh. Okay. So number 13 is a complex fraction problem. So what I typically do with these is I just look at all of the denominators and I come up with a common denominator, which in this case would be xy. And I multiply all of the numerators. So this fraction, all of the numerators by xy. So xy, xy, xy. And in the top, the xy's would cancel, so I'd be left with 4x squared minus y squared. And then in the bottom, the y's would cancel, so I would have 2x minus the x's would cancel, so that would just leave me with y. And then at that point, I guess I could have done this first, but you can factor the top, and it's a difference of squares. So it would be 2x plus y and 2x minus y all over 2x minus y. And so then these would cancel and I would just be left with 2x plus y as my final answer. Okay, what else?
Wait, what Kale was asking, do we have to do the chapter 9 review and the unit 9 review, or
No, just this one I have pulled up.
just the unit 9 review?
Yes.
Okay, thank you.
How many questions on like what is it? Give me a second. It's the graphing one, but not the slant asymptotes. How many of those are going to be on the test?
I think that there are 6 graphing problems and there's like 1 or 2 slant asymptotes.
How many questions are going to be overall like on the test?
I think like 24, 25.
Okay.
So just if there's not a horizontal asymptote, does that automatically mean that there's a slant asymptote?
Mm-hmm. If the degree is bigger on top.
Okay.
Any more questions?
Could you do number 7?
Uh-huh. Okay, number 7, it has quite a bit with it, including this division. So what I would start with is just trying to factor every single part first. So I would start with the top left, which would be, let's see, 3x plus 1, x minus 2, y plus 2, y minus 1, y plus 5, y minus 1 over, I have no idea,
Wait, Miss
3x plus
McKinley?
1. Uh-huh.
How did you get the first set of factored deals, like on the top left? Because when, oh no, wait, sorry, never mind. I read that wrong.
Okay. Does it make sense?
Yeah, sorry, I had flipped 2 of the numbers.
Oh, that's okay. So then we have 3x plus 1, 4x plus 1. And I'm going to go ahead and flip these because it's division and put the 8x squared minus 2x minus 1 on top. So it would be 4x plus 1 and 2x minus 1. And then on the bottom, five x plus 1 and x minus 2. And all of these are multiplied by each other. And then last step would just be to cancel top and bottom. So see these x minus 2s, 3x plus 1s, and then y minus 1. I think that's all that I have. So I would write what's left over, which would be y plus 5, 4x plus 1, 2x minus 1 over y plus 2. Oh, I guess I didn't see these. These 4x plus 1s cancel. So then y plus 2 and 5x plus 1. And then I would be done.
For the ones where you do addition and subtraction, you said that you just find the common denominator and then you see what's missing for them, right?
Uh-huh.
Would you please do a slant asymptote one?
Sure. Let's see. It looks like number 4 is a slant asymptote. So for number 4, I could take out an x squared and I'd be left with x plus 3. And on the bottom, I can factor to be x plus 1, x minus 1. I would not have any holes because nothing canceled. My vertical asymptotes would be -1 and +1. And then for a slant asymptote, I would have to use long division because I can't do synthetic because the denominator is x squared, not x. So I'll come over here and do that. I would put x squared minus 1 on the outside. And then x cubed plus 3x squared plus 0x plus 0. Oops, why did I put that up there? It needs to go inside. So then I look at my first term and I think, how do I get from x squared to x cubed? I would multiply it by x. Then I distribute the x to x squared into -1. So it'd be x cubed minus x. And then I flip the signs. Probably should have given myself some more room. And then I bring down 3x squared plus x plus 0. Then I look at this 3x squared. So to get from x squared to 3x squared, it would be plus 3. And then I can stop because I don't need remainders or anything like that. So not doing the full long division, just usually doing the 2 steps. So my slant asymptote would be y equals x plus 3. For my x-intercepts, I'm setting the numerator equal to 0. So that means I'm going to set this x squared equal to 0, which would just be 0. And then I'm also going to set this x plus 3 equal to 0. So that would end up being -3, 0. For y-intercepts, I'm going to set x equal to 0. So that would end up being 0 over -1, which would just end up giving me 0. And I think that's everything. So now I just need to plot the asymptotes and the intercepts. So I have 2 verticals, one at -1 and one at +1. Then I also have a slant asymptote, which is x plus 3. So that means I have a y-intercept at 3, and it would be a positive slope. And then I'm going to fill in the rest. So I have intercepts at 0, 0 and -3, 0, which would end up being on the slant asymptote, which is okay because things can go through the slant asymptote, they just can't go through the vertical asymptotes. And then from there, I guess those are the only things I can fill in. So I would then fill in the rest of the problem, which I can test points just to be sure. I think if I were guessing, I would probably say it goes down and then up and then up, but I'm not completely sure. And I think, Katie, that's what you were asking earlier, just about what to do in that scenario. So what I would do is I would test 3 points, one on each side of the vertical asymptote. So I've got a section here to the left of -1. I have a section in the middle, and then I have a section to the right of +1. So I'm going to need to test 2 on the middle part because I don't know if it's like, I would assume that they're either both going down or both going up because I have that x squared at the top. But if you want to be like 100% sure, then you could test one on each side of 0 in the middle. So I'm going to test, let's say, I know what it's doing at -3. So let's try -5. Then in the middle section, let's say -1/2 and +1/2. And then in the right section, let's just say +5. And so I don't actually need the number. I just need to know whether it's a positive or a negative direction. So if I plug in -5, I'll just come over here to the left. If I plug in -5, okay, so I look at this factored form. I would have -5 squared, which would end up giving me a positive, because a -5 squared is positive, times -5 plus 3, which would be a negative, over -5 plus 1, which is negative, and -5 minus 1, which is also negative. So then I would have overall a negative on top and a positive on the bottom, which would give me overall a negative number. So if I were guessing, I guess I guessed wrong, because it would be down here. So negative. Then I plug in -1/2. So if I plug in -1/2, I would get a positive number if I did -1/2 squared, and a positive number if I did -1/2 plus 3, over -1/2 plus 1 would give me a positive number, and -1/2 minus 1 would give me a negative number. So then overall, I would have a positive over a negative, which would also give me a negative number. Interesting. So I guess they're both pointing down. Is that what's happening? Does anybody have the key in front of them? Dave Lee, do you have the key in front of you?
No, but I can open it.
Yeah, we open it. I'm just wondering. I'm not going to give you something that's crazy on the test, but it's just for fun. Okay, so then I have it pointing down, so I guess they're both going in the same direction. Unless this goes up. I guess I could test a point between -3 and -1 and see what's happening. If I wanted to be sure. Well, you know what? It could, since it's below 0, it could be doing something like that. That might be what's happening. Because technically, this is below 0. I bet that's what's happening. I'm going to test another point between -3 and -1. That might have been what I should have done in the first place. But if I tested like -2, let's see what I would get. -2 squared. I would get positive on the top and times negative positive on the bottom. So yeah, that's what's happening. It's going up this way. If I plug in, does that look right, Davy Lee?
Is there a separate key for the part we're doing? Because I clicked on the key and it only has the first part and like the open boxes, but it stops before it gets to where we are now.
To number 4.
Well, it only gives, you know, the part that we're like don't have to do the beginning. It only gives that part. It doesn't give the section. But is there like a separate tab?
Maybe I have the old review key pulled up because this is from, I'll have to look. I'll look on my folder whenever this Zoom is over. But I think I figured it out because then this is going in the positive direction. Whoops. So if I plug in +1/2, I would get positive on top, negative on the bottom. So overall it would be negative. So going down. And then if I plug in a +5, I would get positive on top and positive on bottom. So then it would be going up like this.
So why did it switch to the left side, like the far left is going up?
Because I plugged in -2, which was right here. And I ended up getting a positive answer. So that means it was going up. And even though like I plugged in -5 and I got a negative answer, but you'll notice this technically is negative down here. It's just not above it's still above the slant asymptote.
Okay. thank you. So whenever you're choosing what numbers to put in, it's not just like any number in the area. You kind of have to know like what part.
Yeah, you have to be a little strategic about it. I'm still gonna stand by my, like, the two rational parts are not gonna touch. So like this, if this is going up, this is going down. If this is going down, this is going up. And I want y'all to stick with that even whenever it comes time for the test. So that can be like a good way to check if you're doing it right. But I did, when I plugged in -2, which was between my two x-intercepts, it was going in the positive direction. So I knew to draw it up.
Okay. And then you knew that there were going to be 3 of them because there was an x cube.
I knew there was going to be 3 of them because there's 2 vertical asymptotes. So there's always going to be one more part of the graph than there are vertical asymptotes. Because if I just had like one vertical asymptote, then I would have a part of the graph here and a part of the graph here. But if I have 2 vertical asymptotes, then I have a part of the graph here, here, and here. So you're always going to have like one more part of the graph than you will. It's going to be on every single side of the vertical asymptote.
Okay, and you want the slant and dotted lines?
Yes.
Okay. And so the slant can cross the vertical asymptotes, but nothing else can?
Correct.
Thank you.
Miss McKinley, will we have to do long division on the test?
I'm not sure. You might.
Okay. And the key for this is not on Canvas, I don't think.
Yeah, that's what I just realized. So I'll upload it once we get off the Zoom call.
Okay, thank you.
How did you know to stop the long division after just like getting the x plus 3? Why didn't you?
Because I don't need the remainder. So once I have these parts, I'm like, once you get to the constant number, you're done because there's no more parts to the equation that you would need, because your slant asymptote is going to be like a y = mx plus b situation. So once you have the plus b, then you are done. Like, so I got the plus 3. I could just stop there. I didn't need to keep going.
And our slant asymptote will always be like an x, like maybe a number and then x plus another number. Like it's never going to be like x squared because that would be.
Right. No, it won't ever be an x squared.
Okay, thank you.
Wait, why could it not be an x squared? Like, why? How could you not give an x squared at some point?
I mean, it is possible, but we don't ever do anything like that in this class. It's always going to be a linear slant asymptote.
Okay, thank you.
What time will you be at school tomorrow in case you have questions?
I'll be there at 7:15.
Okay, thank you.
Do y'all have anything else specific that you guys want to go through?
And would you please do one of the addition or subtraction ones, like for the fractions?
Uh-huh. So here they all are, 9 through 12. Is there one specifically that you want to do?
How about 12?
Okay. So with number 12, first step is to just factor your denominators. So I would have x plus 1, x minus 1. Here I would want to take out a -2. And then I would be left with x minus 1. And then lastly, I'll take out an x and I would be left with x plus 1. So out of all of my denominators, my common denominator would be -2x, x plus 1, x minus 1. I'm just combining all parts, and the x minus ones and the x plus ones are repeated, but I only need to put them one time. So then in my first fraction, I am missing negative 2x. So I'm going to multiply the numerator by what's missing, which would be negative 4x squared minus my second fraction is missing an x and an x plus 1. So I'm going to go ahead and put this in parentheses and put x, x plus 1, x minus 1. And if you want to go ahead and multiply it out, you can, or you can just leave it as is, and we'll multiply it in a minute. And then plus 4 times what's missing is negative 2 x minus 1.
Wait, why did you add the x minus 1 in the middle?
Because that was already there on the top.
Oh, okay. So you just added
So this, yeah, that one was already there, and then these two are what we're missing. Right.
Thank you.
And then, so then lastly, if I combine these, it would be minus 8 parenthesis x minus 1. So then at that point, I want to start multiplying or distributing. So I'm going to leave the negative 4x squared as is, minus, if I were to start combining these, this is a difference of squares. So it would be x squared minus 1. And then minus 8x plus 8. So I just distributed that negative 8. If I kept going with this, then I would have negative 4x squared minus parentheses x cubed minus x minus 8x plus 8. Now I distribute that negative, so it'd be negative 4x squared minus x cubed plus x minus 8x plus 8. And then finally, combine my like terms. So negative x cubed minus 4x squared minus 7x plus 8. And just by looking at it, the only way I could potentially factor would be by grouping. So in my head, I'm just thinking, there's no way that I could factor this by grouping. It just wouldn't work out. So I'm going to leave it as is. And don't forget that your final answer includes the common denominator on the bottom. So even though I'm like working through simplifying the numerator, my final answer includes the common denominator. Sometimes people just forget to add that in at the end. So don't forget that at the end. And then I'll be done.
Miss McKinley?
Uh-huh.
Why did you only put the middle section in parentheses and not the like anything else? Did you just put that in parentheses so that you would do that first?
I put it in parentheses because this was a minus. So I just needed to remember to distribute that minus. So that's why I put it in parentheses. If it's a plus, you don't need to worry about it as much because the signs don't change. But when you have minus a fraction, that changes the sign of everything in the numerator for that fraction.
Thank you. And will the key that you upload have work on it?
Yeah.
Okay, thank you.
Did you guys have any other questions?
Wait, so when you're adding or subtracting fractions, then you keep the denominator, but when you're like dividing them, even though you have addition or subtraction in the numerator or denominator, you don't keep the denominator when you simplify?
I don't know if I understand your question. Are you talking about like in these examples?
No, like sometimes when you divide fractions and they have addition or subtraction in them, so you have to multiply by the common denominator. and
Oh, like number 13.
So you don't keep the denominator in the end.
You don't have to with complex fractions because what you're really doing is dividing. You're not just adding and subtracting.
Okay. But you could keep it if it doesn't simplify.
Yes.
Okay.
So for ones like number 14, you have to find the common denominator of the top one and then the common denominator of the bottom one, but then you don't have to have a common denominator to divide, right?
Right.
Okay. So you don't have to have a common denominator of all 4 of the denominators, just of the top 2 and then just of the bottom 2.
Yeah, that's one way that I taught you guys to do it.
Thank you.
So if that's the way you prefer, then stick with that way.
Got it.
Anything else? Okay, then I will upload the answer key. I'll do that right now, I guess. I just made this review last year, so that's probably why it's not on there, because it was COVID and everything. So I'll upload that, and then I think I still need to create the assignment. So just be looking for that, and then tomorrow I will be here at 7:15. If you guys have any more questions, and then I'll post this video on Canvas as soon as I can.
Oh, wait.
Any last minute things?
Okay. How similar is the review to the test?
I think it's generally similar. I mean, I don't think there's any surprises on it. It's just graphing, multiplying, dividing, adding, subtracting, solving.
Okay, so if I
So
entire review, then I'll be good.
I hate using that term, like you'll be good, but I think
Okay.
it'll definitely help.
Okay, thank you.
You're welcome.
And you
All
said
right, well, let me know if you need anything. Yeah, Katie.
you wouldn't have any slant asymptotes that were like the one we did that was like that? Or could there possibly be?
I don't think the slant asymptote problems will be as complicated as the one that we just did.
Okay. Thank you.
You're welcome. All right, you guys have a good evening. Let me know if you need anything. I'll see y'all later.
Thank you.
Bye.